My name is Achim Kockler. I'm the General Manager of INNOPERFORM. INNOPERFORM has been dealing with the topic ventilation through the closed window for many decades now. And we are representing the low-cost ventilation for many, many years. In 2018, we have launched an innovation which is called arimeo. And today I would like to convince you that although it is such a complex topic, ventilation is actually something that works quite easily. This is why the title is Ventilation Made Easy with arimeo. Let's imagine that you are participating in the renovation of a big object, a big residential house where all of the windows are being exchanged, insulation is added, perhaps something is also done at the rooftop, and you have actually invested a lot of money and you had a thorough planning. You're very proud that now you can really offer something to the future tenants. You're very proud of the measures that you've taken. You have reached a modern standard. And in the first heating period, in the first heating season, the tenants will call you and say, okay, we do have mold in our apartment. This is a very unfortunate scenario that still happens quite often, but which used to happen much more often in the past. What do you do then? You make an appointment, an on-site appointment, and then you get into this apartment, you say hello to the tenant, and the first thing that you do is that you are taking a hygrometer out of your bag and you are reading it in the living room, 75% of air humidity. And then it's quite clear, well, 75% humidity, this is certainly what produced this mold. And if you have 75% of air humidity in the middle of a room, this means that at the outer wall, it is much, much colder. So this threshold layer at the outer wall, if it has at least 85% of air humidity, then mold will certainly be produced. And this is what happened in this apartment, because if you have 75% in the midst of the room, you will certainly have much more than 80% at the outer shell of the building. And then you explain it to the tenant, and for you it's quite obvious what needs to be done. Together with the tenant, you go through all of those rooms and try to really open all of the windows, completely exchange the air volume in the rooms, and do the so-called shock ventilation. And then you get back to the living room, take out the hygrometer, and you see 35% of air humidity, and you have achieved your goal. And then you say to the tenant, okay, this is how you do it. Please do that every single day, and the problem will be solved. And then you might chit-chat a little bit with the tenant for half an hour or an hour. And then you take your hygrometer, and before you put it back into your bag, just, to play it safe, you look at it and you see 74% of air humidity. And this is when you really have to start thinking, because this would be something that will tell you, okay, something is going awfully wrong, particularly when you think of the building physics. And if you want to find out what exactly happened, you have to think of two aspects. In every apartment that somebody lives in, constantly there is humidity. You take a shower, you put, for instance, the towel on your heater, you are, I don't know, pouring water on your plants, you are breathing. All of that is happening every single day. So there is a lot of humidity that is produced, and this humidity has to be gotten rid of. So you need some sort of balance between producing humidity and getting rid of it. So this balance needs to be strict. And as soon as this balance is imbalanced, air humidity will build up. And the second thing that you have to keep in mind is that it is not only stored in the air, but you have other storages in these apartments, namely the walls. And these walls can take up masses of humidity. And this is exactly what happened in the apartment that we've just talked about. You had the shock ventilation, you only had 35%. The humid wall is happy because finally it can give off and release the humidity to the air, and it does it as long as there is a balance between the room air and the wall. And this is what brought it back to 74%. If you now integrated arimeo in such an apartment, it might take a whole heating season before all of the humidity was released from the walls that stored it. Of course, smartly enough, there are other solutions. However, you would have to make sure that the cost for all that is getting up a bit off. So all of the humidity that is produced in an apartment needs to be transported out of it again. These cases have already existed in the past. Then there was a time where there was a lot of mold production, a lot of mold damages. Now we have a standard, a ventilation standard, a DIN standard that tells you that a moisture protection ventilation needs to be provided by the building itself. So it cannot be expected from the inhabitant, from the people living in this apartment, that they take care of that. Of course, they can smell something. They are getting tired if the CO2 content is too high, but they don't know whether it's 35 or 65% of air humidity. This is something that nobody can be expected of, which is why there is this thin standard, namely the user independent moisture protection ventilation. And if we just look at ventilation through the ages, this is the way in which people used to build houses in the past. If you just think about this moisture protection ventilation level, the one red dashed line, this is what needs to happen in order to prevent any mold damages. So all of the air that was automatically exchanged through the walls was much higher than that. And what did the users do back then? Well, they tried to use common sense, and when they had the feeling it is necessary, they just opened the windows manually and closed them again. And this led to a total air change, which in some cases was higher, in other cases it was lower. But one thing could not happen, namely mold production in this apartment. This is what the building is responsible for itself. And then we started to build in this way with a very dense construction. Again, we have this nice red dashed line, moisture protection ventilation, but the leaks, they were reduced. So this was a gap that was actually closed by the users based on their way of ventilating the spaces. And over time, a lot of mold damages came to being. So it doesn't mean that necessarily there has to be mold at the end of the day. However, in these buildings, this was a very frequently observed consequence. Again, this was taken into account in a dense standard, and today we build like that. We still have a very dense construction method. However, based on this standard, we are calculating the the leaks, and then we are calculating the gap that needs to be fulfilled until we have moisture protection ventilation. Here it reads LTM. LTM means that it is a ventilation measure. And then there are some ventilation measures that are ensuring a total air change, for instance. But with us, with arimeo, we are talking about a minimum. And we talk about low cost ventilation. This is something that you need to have based on the building physics. For us, it is about trying to close this gap as precisely as possible with as little air as possible. You see that it is only a small dash of air that will actually restore the balance of the building physics, but you need to close it in order to avoid any problems at the end of the day. And of course, the closer I get to this minimum, the less energy do I actually consume. So the smarter these measures are. So what was actually done then when we have discovered this gap? We try to find a simple solution to fill that gap. And if you look into the ventilation standard, of course, you can interpret it in different ways. And there is a whole plethora of different ventilation systems that could be used to this end. Whenever we have a new building, there need to be concepts for ventilation, also for refurbishment measures. For instance, more than one third of all windows are exchanged because the building shell needs to be changed to such an extent that you really need to make sure that you have the right ventilation measure to avoid mold building. And most solutions are there for actually ensuring a total air change. This is not what arimeo does. Arimeo tries to meet the DIN standard and at the same time avoid mold building. And you can actually achieve that with the so-called cross ventilation. In this standard, there are two big chapters. One chapter is called free ventilation, and the other one is fan-based ventilation. And with respect to the free ventilation, this is basically addressing the low-cost ventilation, the key element of which is the window. And here we have, among other things, the cross ventilation, by means of which you can get rid of those mold damages. Of course, this can be calculated as well. So you can calculate how much arimeo you need in your window. So wind driven without any fan technology. On the side that is exposed to wind, air is let in. So here you can see that this happens at this corner. And on the other side of the apartment, the air is pulled out again by the wind. This is something that works very efficiently, and you can also look at the wind pressures that need to be expected during the heating season, as is provided in this DIN standard. And you cannot actually imagine it as being like a lot of air that is being transported. No, it is only some sort of very fine ventilation. And then we also have a calculation tool that helps us finding out how much ventilation is necessary in any one apartment. This is available as an app, but also on our website. If you register and log in there, this is a planning and calculation tool. We try to visualize that in a graph. Here you can see different levels of ventilation. The lowest being the moisture protection ventilation. And you can again calculate that in cubic meters air per hour. Then it is also involving the nominal valuation. It is some sort of total air change. So it's a ventilation technology that targets at exchanging the entire air volume. But this is optional in this standard. So you can choose any of those ventilation options, but you can only also use the moisture protection ventilation just to protect the building. The rest is then done by manual window opening. So this is allowed. There are many misunderstandings that this is not allowed. No, that's not the case. You cannot actually put that at the same level as ventilation technology. So it's only this minimum concept that is required, and the rest can actually be ensured with arimeo. I can show you what is so specific about arimeo. Arimeo is where all of these sensitive ventilation is made possible. And here, for instance, you have the rebate ventilators that allows a minimum airflow, something that actually has existed for more than 20 years now. However, the conventional window rebate ventilators that are integrated into the frame, here you can see the big fittings with all of the bolts, screws, and stuff. Of course, they are actually competing with the fitting elements because they are provided in exactly the same space. And ever since many ventilators need to be integrated, particularly for moisture protection ventilation, and also since there are so many fittings assembled and integrated in windows, this has actually led to different problems. And now Arimeo came up with a smart little solution, and I just want to show you with this window how it is assembled. The Arimeo idea is very simple, namely taking a part of the interior insulation of the window slab, use the Arimeo element here, and clip it in. I hope you can see that on the camera. So you heard it click, right? So here we have the flap. A flap control showing a very small picture. And this is a space that you cannot even see in practice. Because as I said before, here all of the rebate ventilators are provided and accommodated for. So this is a very discrete solution that can hardly be seen. And it is very small and compact, which is why it can be integrated in any fitting technology. Due to that, Arimeo is a fitting independent window rebate ventilator or ventilation system. And this only worked because we have provided three component cast molding technology. We have integrated different functions in this one module, in this one element, in a compressed way. And they are absolutely necessary because it's not possible to just take out a part of the installation. We have to sort of replace it by technology that can sense the wind and the air and the airflow and react accordingly. So this is why we have two control flaps, and these control flaps are attached to the casement joint, and this enables a movement of the flap. And this movement again is controlled by the wind. And this makes sure that air is there whenever it is needed, namely when the wind is very weak, when there is normal weather outside. Then this very sensitive moisture protection ventilation needs to be there. However, if the wind is stronger, I would actually use up energy through this slit. And this is something that we do not want. So if the wind is getting stronger, the flaps are automatically lifted. And with that, they close this little gap. And that way you can also avoid energy consumption and no draughts, which is of course also very important. And then here we have a snap-in element where usually there is the installation, where the installation feed, we have the snap-in element, and we have buffers made of a rubber-like TPE material. And why did we do that? Well, because here it is replacing a part of the insulation, and insulation is also breathing. It needs to be flexible for a reason. Namely, this insulation needs to balance out, for instance, that the fittings are adjusted accordingly, and that due to the wind, perhaps this window is breathing to some extent. And this is what our ventilation system needs to make sure as well. And if we look at the cross section, you can see how tiny and small this element is. In red, you see the arimeo part, and it is really only sitting in this one space that is usually used by the installation. And only because of that are we able to overcome all of the fittings that are actually assembled in this area. And we made the entire width of the window usable for ventilation. So here in the left, on the left-hand side, the flap is closed. You can see it shown in red. And on the right-hand side, you see the closed window. Another big advantage is the modular character of this construction. It's always the same ventilation system in the PVC windows. You can provide one, you can provide two, or even three of these arimeo elements, and that's it. Because this is a air volume that, from our point of view, cannot be done any better. I mean, of course, you could provide a fourth one, but I don't think that you need these huge amounts of air. For us, it's only about making sure that the building is protected, that there is moisture protection, and we have 6 different variants that are called single, double, and triple embodiments. We have single acoustic, double acoustic, and triple acoustic. And these variants make it possible that with the same ventilation system, the air is coming from a different guiding channel. And these 6 variants are actually enabling planning different volumes of air that are appropriate for the respective apartment, that you still have the tightness against driving rain and also the ventilation properties that are required. And we have also had all of that checked by the TFT, also the sound insulation. When it comes to processing it and assembling it, arimeo, it's very easy to assemble also because of the fact that it is independent from the fittings that are used. If, for instance, an architect has an RFQ for a specific number of ventilators or ventilation systems, you do not have those restrictions because you don't have to, find your way anywhere else in this window. There is some sort of standardization that is made possible, namely that the ventilators can really be put at the top of the window frame without any improvisation required. Arimeo has thus really made the assembly much faster, much easier, less complicated. You can, of course, have a look at it, something that can be done very quickly without facing any problems. And on top of that, you have some sort of a cycle time neutrality with this product. So there is not the necessity that you have to adjust the frame to the window sash. No, that's not necessary. Arimeo can be integrated wherever there is time to do so, no matter whether it is once that the window is finalized or at some stage before. My last point before I show you the experiment, and I hope that I'm not stretching my schedule too much. Of course, you can ask yourself, okay, all of that is wonderful, very easy, uncomplicated. We have the cross ventilation, protection against mold formation. But there are some apartments where this does not work, right? And you're quite right with that. Of course, there are some apartments that are aligned to one side only. We tried to show that on this slide. So apartments that have the windows only on one side of the facade. And of course, cross ventilation will certainly not be possible because there is this wind side where wind is coming in, but the wind doesn't have any exit. And luckily, these are apartments where almost always there are windowless bathrooms. And I've showed this upward arrow. So in most cases, it is some sort of airstream that ends on the rooftop with a centralized or perhaps a decentralized ventilation system. But those windowless bathrooms have to use ventilation systems that are integrated according to another DIN standard. And you are using this bathroom ventilator in an apartment to get this under pressure to exhaust all of that. So at that time, you are sort of providing fresh air from arimeo through the windows in order to ensure that there is moisture protection ventilation in an apartment. So with those apartments, again, you have a low cost ventilation concept and killed two birds with one stone. Now you see this wonderful bottle here, and people might say, okay, why do we need every meal? If we have a ventilator, we already have ventilation. Okay, I'm going to show you an experiment here. So this is a very typical bottle with a seasoning, liquid seasoning that is very typical here in Germany, something that everyone really likes using. So this is a conventional bottle of this seasoning, but without the seasoning, only with water. And if you look at it here very closely, you can see two openings or two little pipes. And you have to cut open these two, well, pipes. And once you've done that, you can really refill this bottle. However, if you just close one of these two tubes, the smaller one, for instance, you see that nothing comes out of it, although the big one is still open. How can that be? It's a huge cross section, and the full mass of the water is actually putting or exerting pressure on this little pipe. Well, it's quite obvious because I have closed the small ones. So for any medium that is enclosed in a dense body, if one medium exhausts or is exhausted, another medium needs to get in order to replace it because otherwise there would be a vacuum. Look at that. This is exactly what happens. Water is flowing out of the bottle, and you can see that some air bubbles are formed because the water is replaced by the air that is going into this bottle through the smaller pipe. And if you have an apartment that is perhaps relatively dense, and if you sort of forget to plan arimeo and to provide arimeo in the window frame, nothing will happen. It will not work. The entire ventilation system will not work. Except that you have used arimeo, then of course you can see that the water or the air in our case will flow and you will have a functioning ventilation system that is in accordance with the DIN standards.